Okay, welcome to the Chapter 4, Section 1, Classes, Objects, and World-Level Methods presentation lecture. As we move on and get into some later chapters here, you will realize that some of the programs that we are going to write are become larger, which means they're going to require more code. And when it comes to requiring more code, you can have lines and lines of code, and the question becomes then, as a programmer, is there better ways of organizing this code so it's easier to find certain lines of code and modify it if needed? Games and other real-world software applications can have thousands, even millions of lines of code. So better organizing this code is definitely in our best interest as a programmer. Classes, objects, and methods. Object-oriented programming, which is what we have been doing, utilizing classes, objects, and methods as basic components. These components allow the programmer to help with organizing larger program into smaller modules, as well as design and think about an intricate program, and then finally finding and removing bugs or debugging the program if it's not executing properly. Now, in past programs, we have been using different classes. Now, in Alice, classes are predefined as 3D models. So we have in this example, fish, flamingo, frog, and goldfish. Now, when it comes to objects, an object is an instance of a class. So for example, you might use the frog class, but if you have more than one frog, the frogs are going to be named frog, frog 1, frog 2, and frog 3. The class is an uppercase name, the objects are lowercase names. We have also used built-in or predefined methods. For example, move, turn to face, say. Those are examples that we've used in our examples and your exercises. We have written all of this code in the world.myFirstMethod window. So the example is in the first encounter world that we have been working on over the past couple of chapters, we wrote all of the code within that myFirstMethod window. What we will be doing now is we will be writing our own methods and then calling them in that myFirstMethod window. Here's what the code looks like currently. This is exactly what we have in there for that program that we wrote in chapters 2 and chapter 3. However, you can see this is a very simple program. What happens if we were to add on to it, expand it, create levels, if this was a video game or a movie or something like that? How can we better organize this code so it's easier to find certain things, debug them, make modifications? All right, so the potential problem is the program code is just going to grow and grow and grow as we add more elements to it. So if we continue to write programs this way, the programs will become longer and more difficult to read and even think about. So what can we do to ease that process on ourselves? The solution is to organize our instructions into smaller methods. So a possible storyboard could be breaking down all of that code into 3 specific method tasks. The surprise. In the surprise method, the spider robot and alien on wheels are going to surprise each other. Then the investigate method, in which the spider robot gets a closer look at the alien. And then finally the react method, which is when the alien on wheels hides and the spider robot sends a message. Let's take a look at how we're going to put this into play. All right, so the next step then is to break down each major task into smaller, simpler steps. So the surprise method would consist of a do-in-order control structure, having the alien on wheels move up, having the alien say slippy toes, and then finally the spider robot turns his head around. Okay? By doing this, we are putting into play a process known as stepwise refinement. This is breaking a problem down into large tasks and then breaking it down even to smaller, simpler steps, and that's what we call stepwise refinement. Now, once the storyboard is completed, we can now write a method for each individual task that we want to complete. We can do this in the Alice world by clicking on the world bubble in the object tree. Then when the world's details come up in the lower left-hand side, we click on methods, and we can click create a new method. We can then name the method, and then we can write the method and call on it whenever it's needed. All right, so let's take a look at the demo. We'll take a look at the first encounter world, which is the code that we have already written, and we're just going to organize the code a little bit better and create these 3 different methods and then call upon them when needed. Let's take a look at how this is going to work. All right, so here we have, this is it. This is, if I go back to this is my first method. This is where we have all of that code currently, but this is the solution. This is what we're going to fix, and how we're going to modify this program is we are going to write a surprise, investigate, and react method. So if we take a look and break this down, here is the surprise method broken down. So the spider robot encounters the alien on a distant moon. Alien on wheels moves up. Alien says, slithy toes. Spider robot's neck and head turn on revolution. Going back to this, after executing the world surprise method, then we wanted to execute the world investigate method. The world investigate method, as created, is right here. A little bit more code in here, because this is going to include the alien walking. So take a look at this. We're going to do all this together as a class, so you get practice doing it. And so then after that, the investigate method will happen twice. Then finally, the react method. And the react method broken down is the alien on wheels moving up for a duration of a half a second, then turning and facing the camera, then his neck and head is going to turn red, and then the spider robot says, Houston, we have a problem. So that's taking what we have and just breaking it down into a lot simpler steps and breaking it down into pieces for easier modification if needed. Okay? All right, so moving on. All right, so why do we want to do this? We want to write our own methods because it saves time, it's going to reduce code size, and it's also going to allow us to think at a higher level, which is also known as abstraction. So by doing this, it actually is going to make things easier. You might be thinking, God, it doesn't make sense to be putting all these things all over the place and then calling on them later. But as the codes get bigger, as the programs get bigger, and the code that's being written for these programs is becoming more intense, these are going to become methods that you're going to use, tactics you're going to use to make your code writing an easier process. All right, so hopefully you have already read chapter 4. If not, make sure that you for sure read chapter 4, section 1, and review world level methods, as well as how to create them, how to call them, and then when is it appropriate to use them. And then we will also be assigned a section 1 lab. We will break chapter 4 down into 3 sections. This is section 1, and we will move on to section 2, and then finally section 3. All right, this concludes the chapter 4, section 1 presentation lecture. We'll see you back here for the section 2 presentation lecture.